So, hello. I hope you can hear me well. Let me just say hello to you. Hello. Yeah, please let me know in the chat if you can hear me well and see me well. We can proceed. So, we'll share the Jamboard. So, can we proceed? Proceed. Plus, minus. If there's any problem, let me know. Okay, I see one plus. Where is the second one? Hopefully sometime later we will have more students, but now this is very exclusive for those of you in these tutorials. So okay, are we ready to proceed? Okay, great. So then first thing to do is please download template, and the template is here. It is also in the notes of the live stream. So yeah, so is template downloaded and ready for work. So at some point, hopefully you will be able to proceed with your own code with between sessions. But right now, I still think it's a little bit better to that you use my templates every time we have a new session. But we will look definitely at the homeworks and the previous template works as well in the beginning. So please download those templates and let me know when that's ready. And I will move to the PyCharm now. So yeah, so you should have the template, something like that. And if you try to run it, so if you try to run your code, remember that you must set the so yeah, so it's not working as expected now, and it's actually it is working as expected, but the reason why it's like that, I will let you show you. So here I should press edit configuration and then set emulate terminal, then OK, and then it should then work nicely. Yeah, so it's not moving anywhere else. Okay. Yeah, so that's what you have to see now. I hope that you can get to that point yourself. And then we will examine your homeworks. That was great that you submitted it. So is the template ready for work? That's our question. Plus minus. When you're ready, type in plus. And then we examine the homeworks and hopefully help you to understand a few things, make them work, explain some things. Cannot download. That's interesting because I have one plus here as well, so it should be possible to download. Or you mean that you're not at the computer? What do you mean? So let me know in the chat. So the download works, at least I see it's working, so I can drop it again here. It should be working anyways. Yeah, so please clarify what you mean by cannot download. I'm on Ubuntu, so that no problem. Just so with Ubuntu, it's even easier. You type in wget and add the template at the end, the link, and it will download what you need. So I can even show you here. So let me see. So do I have it? Yes. So terminal. So if I try to do something like cd, let's go to downloads, and then wget. So that's, you can do that on Windows, but you can copy the template like that, no problem. Super easy. I don't know what you mean with your Ubuntu. Hopefully you can fix it yourself. Yeah, so meanwhile, I will try to, so if the rocket has some problems, I will wait for you. But meanwhile, I will start showing some of the things in the Christiana's homework. So this was the Christiana's homework submission. So we see, I added some notes here. So you created the player and then you created the rocket. By the way, both of you created the rocket as like some kind of object that you will reuse, not something that is created on the fly, that is interesting but acceptable. The problem that is not acceptable is here, big bug. So this is something we have been talking for multiple sessions, and it's something that I really hope that this time you will start getting to understand. So let's start by looking at this 130th line. So we have a position here, and we could even add a breakpoint to explore this a little bit more. So if I stop it just on the rocket here, so let me show you what is that big bug here. Big problem, basically bug is in the programming lingo means that that's very bad problem. So here, let's say we have the position. So let's see. Okay, I cannot get the pointer like that. Anyways, so we can see pointer actually here. So uh, if you look at the colored line here where I show you, so you see at the end it shows what is the memory address of this instance of an object. Memory address. So this is where the memory is stored. So it's written 133ADFE20. So that's your memory address of that object. It's actually also visible here, not here, but here. So the memory address is that. And then let's look what is the memory address now to this player.position. And you will see that these two that I show here have exactly the same memory address. Everything that you change in one will change something in other as well. So let's keep moving. So if I add the breakpoint here on this line and press this button on the left side bottom part where you resume the program, F9. So if I press it, we go to this part. And now let's look what is the rocket.position. Rocket.position also have the same memory address. So you have three instances that have the same memory address. So what it means, if you change anything in those three instances, it will automatically change in all of three other instances. So they are not copies of the data, they are pointers of the same data. So let me check if that is clear. So let's ask the question in the chat. Is this problem clear? Plus minus that you are right now have pointing to the same memory location of the position bottom middle for the rocket position and player position. So all three instances of an object are basically exactly the same, and they are not the copies but actually the same memory location. So if it's so I see rocket is saying plus. What about Christiana? Maybe in the chat somebody can type in then how we should set the positions to the player and the rocket so they would not be the same memory location. Like what would be the other way how to do this? Then maybe you can try to guess in the chat or write if you know. So how to solve this? So if the problem is because if I, for example, now I will even demonstrate that on live here. So see pause bottom middle x. I will say set x as 10. So let me check what was the x. So x is 5 here, and if I set x as 10, you will see that immediately also the x of player position is 10, rocket is 10, and this one is also 10. So just with one line, I changed the output here for three other variables because they are actually the same variable, just pointing at the same memory location. I hope this is clear, really hope. So yeah, so the rocket is saying that we should set the position by setting x value of the other position. But by the way, we already implemented the property, so we don't need to call it like that. We can just like directly use the equal sign because there is this the property works like that. So, but let me show you some ways how to resolve that. So let's start with first one. So we have position here. If we want to use this syntax, then what we can do is we can have the position to the position x, y, like that. And now we have a new object of position, and this memory address will be very different than this. So this is one way. So this is option one, how to do. Option A. You also can reuse something that's already existing. Option B is to set something like Rohit said, something like this. So this would be also completely okay because the position here is already initialized inside the player and we are just reusing it. It's not actually setting complex type. The x and y is simple type, and that's why we can do that. So like floats, integers, they are simple types. So both options are good. We can comment out or choose whatever option we want of these, and it will work. So that's for one. Also for the rocket, then we also need to do the same thing, basically, because we don't want this to be linked with the player. So if I change anything in the player, I don't want that my rocket also changes. So let's do that like that. So I will drop these lines maybe in the Jamboard as well. So they are specific to the Christiana's work. So that's an exclusive opportunity that you can use that I have. So you're on this tutorial, only two of you right now. Those of you who are watching later will not have this exclusive opportunity. Hopefully they can learn something from your mistakes. So yeah, so we'll have these position settings here. So that's fine. Then the other thing is you say that you did not add the rocket to the elements, and that's correct because we should add rocket to the elements only when we fire something. So let's move this line to position here where we add it to the firing here, rocket up and then fire. So one thing that Christiana did right, and I think rocket somehow missed completely, is that you already have very well functioning like a movement system that is tied to the direction and speed and all sorts of delays. So there would not be different behavior depending on your computer speed or how fast you press the buttons. So you use the Rocket app, so this is very good, very good. But then you did not add it here, so which should also be done here. And then the last thing missing here is that the position that you set up here actually need to be set down here, and this position should be copy of the player position. So we can just use player here, and it will start flying out from this part. So I will add this part also to the Jamboard. So this is more specific to this case exactly, but we'll look briefly also on Rocket's case, and then we will start developing the template. So this part. And then the last part is that you have the collision detection, but there is no check if the collision is something like between the wall or the rocket or something. It will just end the game immediately if it detects collision even with the player when it shoots it out. So this is not something that we want. So we can add, actually, we can comment out these parts, probably add it as a pass. So the pass means that we do nothing, just like, or you can just delete all of this for meanwhile. Maybe we can do that. So delete just this part. So now if I run it now, let's see what happens. So first of all, the spaceship very nicely flies in both directions. It does not fly. Oh no, it flies also top and down. So there is another bug. Um, so the spaceship should not fly up and down. So we remove these lines as well. We should not fly up and down. We just need to fly in the bottom part, if you know that game. So let's run it again. So now this is working. So if I shoot, okay, if I shoot, I had a problem, sorry. There is a bug here. It should be position, and here as well, position. So I will update the Jamboard briefly, and now it should work. So only there is one part as well missing, is that I don't see the check for the exit of the screen. So if the rocket flies outside the screen, on top of the screen, it should not like continue flying forever, you know, or just stuck, because I think it will be stuck because we have some constraints there. So let's see. So if I shoot, yes, the rocket flies. That's great. It just did not destroy anything, and it will be stuck at the top part, I think. So you see, Christiana, there was not that much needed to change, but basically one kind of very important part that is necessary to understand regarding the object pointers, the memory locations, and actually what is inside those objects. That is very, very important to understand. Okay, so let's move to the rockets example then. I will double check if you don't write something in the chat. No information. Okay, great. Not maybe not great. So anyways, so let's see then what rocket done. So let's run it. So we have little bit different configuration. The walls are in the middle of the game, so everything is working. I cannot fly upwards, so that's great. But I cannot. Oh no, I can fly backwards, so that's great. It's not stopping. It's not yet implemented stopping. Oh no, I can stop it somehow. How did I stop it? If I press in the opposite direction, you add plus and minus. So the more I press, the faster it goes in some direction. Do I understand correctly? Did we had it like that? No, we didn't have it like that. So you added option to stop the ship, but you also added something like this. If I press it very quickly, it will just fly like crazy fast in one direction. And then to get it in the opposite direction, I need to press like hundreds of times. That's not great, but it's interesting solution. So then if I press the space, now I get the rocket, and I guess I pressed it too long because it just crashed immediately. So you did not check if you collided with yourself, I guess. So let's try again. Okay, now it worked. And now we have even this nice, uh, this very nice explosion here. So that's a great job. But anyways, so still, see, it's still not working very nicely because you can press it quickly, something, and then it crashes. So let's look at your code and examine in detail. So this was interesting addition of having the adding the speed, but also not very, maybe not the smartest way, because you need to somehow you can press many times button and then it will be very difficult to get in the opposite direction. So that's not great, but interesting solution. So then regarding the rocket, so you use for the rocket you used exactly the same player, which is kind of fine but not great, because we already talked about object-oriented programming, and you should be able to extend player class into rocket class. So that should not be hard for you, I think. So that's one thing. Then I see that you also predefine rocket as a global variable, so that's interesting. It might not be as well like that. So then here you set the position of the player, so that's great. Then you append it to the elements, that's okay. But then I think the worst part is here. So all the other parts are kind of okay, but this part is not okay. So I don't see any reason why you would want to hard code modification of the position using something like this if you already have all of the logic necessary for moving objects. So this is like doing very backwards everything. So you should never ever do something like that. Yeah, instead, you just use the logic in the update. So that's already like done here. So you change the positions here. So you don't need to do that. Also, if you would have rocket element, you would be able to, I mean rocket class, you would be able to change the speed for the rocket class more easily. Now it's kind of the same as for the player at the initialization. Of course, you can change it here, but so then we can call it up like that, and it should be fine just as it is, except this part is also not really great. So you add the explosion, but the collision, there is no checks for the types of collisions. So let's see. So if I run it, hopefully it will not crash. So yeah, it shoots out, and it works in a consistent manner instead of working with the some kind of hard-coded delta. Okay, so I hope that's also clear to how to change this part. So you had really few changes necessary here. At the same time, also I really don't like the way how you like kind of change the directions with the accumulation, but still that's fine. So I hope that's clear. So let me check. So is all clear so far? So far, plus minus, and then we will move finally to the new things. So is it everything clear? So if everything is okay, then type in plus and we will move on. Okay, great, 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 great. Okay, so we have been looking at the code for a while. So now let's look at the Jamboard, and I will try to explain few things for today. So for today, we're going to look at a very interesting design pattern called Singleton. So Singleton is a class basically it's a class and instance at once. So you already know that you can make a player, movable object, wall, whatever, right? These are all kind of instances that you can use. So, but at the same time, we want actually often something that is kind of like a global variable set. So we will make the singleton for game state, and the game state will contain as an member variables basically the score, for example, right? The elements is game running, and so on. So what I mean by that is that of course you can have as a separate variables like global variables the elements, the is game running, the player, like we already have it right now, right? They can be global variables, but the problem is then when, for example, if I want to save my game and continue playing it later, then I have no really good way how to do that. Then I need to go collect all of my variables and then save them in file, and then later load them each one by one. They are not in the same place, all of them. So the singleton allows us to create a kind of global state. Basically, it's kind of like a global state that can be restored easily, and it's also structured better. So and structured better than global variables. I will show also how it works in a second. So then if we look at what we have in this UML class diagram, right? You already know some of these things. So first of all, what we see here is, so let me add some colors here. So we see here the private variable, private member variable. So this is private member variable that we know already. So I will point to it just in a second so you don't mistake it. So this is the small thing here. Where is some kind of arrow? or let's say, so this is the private member variable, right? Then this is the constructor. So this is init, right? That we already using constructor. So this is init. This is constructor. It's always called when you create something the first time. Not the first time, but basically every time you create something. And in Singleton, option will be that you will create only once the Singleton. So there's another like property, the Singleton can be only single instance within all code. So I will show you maybe in other files, like in very simple way how it looks like, and then we will implement it in the code actually. So that's another thing. And then here you see this is a property, right? So this is a getter. Property getter. The only thing here that's, so there's actually two things that here that are out of the place. So first of all, one thing you should see that the type here is not a simple type. This is a complex type, and the type is exactly the same as the class itself. So it means that it has a member variable that is initialized out of the same type as itself. So that's a little bit tricky, but you will see that in a second. So that's one interesting thing. The other interesting thing is that you see there is these underlines here. So you see this is underlined and this is underlined. So this means that these are static. So these are static static functions and variables. I will show you in a separate file actually what all of these things mean. Maybe it's even better if you code with me to do this small experiments, and then we will code it in the game itself. So this will be what we have for the game state. And yeah, so let me go back to the pie chart. Let me check. No comments. Okay, great. If you have any questions, type in the chat. So now I also suggest that you make a new file, because I want a little bit work through the singleton sample. So this will be really dumb simple singleton sample that we need to look at before we can move with the implementation in the actual game. So let's see. So let's do the same as in the example of the in the Jamboard. So there will be the class Singleton. It can be, so there's one very important thing. For design patterns, if I have observer, singleton, MVC, whatever, so they should not be called the same name as design pattern. So in this time we call it singleton, but maybe we should call it something else. So let's call it like the game state, like we have another part. So because the design pattern is just like a kind of recipe, like formula that you use, but it's not something that you need to write in the code that this is singleton. So we have it here. Then we will have the static variable. So the static variables are not defined inside the constructor. So here we'll have the instance, and it will be none by default. And then we will have the constructor, of course. Then we will have the super calling of the instructor. So constructors always should call superclass, because sometimes later you can change this to be some kind of subclass, and then you will need to rewrite something, and it will be very dangerous. So please always use this notion. So we'll have this part ready, and then we have another function, def get instance, and this will be the getter, and this will return the game state dot instance. So you already see that this notation, the way how we write it, it's very different than the way how we wrote it before. And also here we will change something, static method with an @ symbol, and without self here, no self here. So this part is the static private member variable. Actually, it's protected, but it doesn't matter. So, and here, this is a static member function or getter here in this case. And this is way how to access static functions and member variables. So this will be this thing. Also let's create some other things here. So don't write the green comments, please. So let's see. So here we'll have the so if instance, if oh no, game state instance is not none. Again, if game state instance is not none, if it already exists, then we will, let's make something very simple here. So then we will exit here and just write very bad. We will crash program now. Crash program. Singleton cannot be init twice. So Singleton can only be initialized only once, not twice. So the game state is the same for the whole game. It cannot be two game states. So that's one thing. Then also we will have game state instance, and we will put the pointer of itself to the instance like that. And now we're missing only here if game state instance is known, then for the first time we call the get instance, we will initialize it, game state like that. I know this might look a little bit confusing, but bear with me. So try to write the same thing without the green comments, and we will add here also some dummy variables. So self dummy variable. So we'll add this as let's say 10. So this is just for the example. This will be our game state, or let's not dummy variable but score. So we will have the game score, right? So and it could be in the beginning, it could be 0. So now here below, how to use it would be something like this. Don't worry, I will give you time to catch up. So get instance score. So it would be used something like that. So we will write print score is this, and then we can also change the score. We can add plus something, plus 10, and then print again. So then we will have 10 score. So I will try to run all of this. Sorry. Yeah, so it works. And basically every time when we access the kind of the global instance of variable, we are accessing through this kind of syntax. There is another way how to access it a little bit nicer, maybe. No, but this will be fine. So get instance like that. And so yeah, please try to catch up with this part of the code. I will add this also to the Jamboard, and meanwhile I will give you a small example below this of another way how to make a game state without the singleton, and then we will compare what is the difference if you use singleton and if you don't use the singleton. So I will add this in the slide number 4. If you have any problems and misunderstandings, don't understand something, please write in the chat. So that part. And meanwhile, you don't have to write this bottom part, but I will just give you examples. So there will be class game state non-singleton object, and in this case, so we can have def init super. By the way, if you have this kind of syntax, that's also okay, but I like it, keep it simple like that. Then self score something like that. Yeah, so okay. Um, Regarding the static variables, maybe I should show also some example here. Okay, so what we can do is first regarding the singleton. So non-singleton, one, we can create a new instances of these classes, as many as we want, and all of them point to separate memory address, of course, and all of them can store different scores, right? If I add here score 20, score 30, and so each of them will hold different score, right? So this is very simple. This is very understandable, right? But if I would then create the singleton type of game state, where I have game state like that, the first time I call it, it will work. The second time I call it, it will have the error. So I cannot create two singleton game states. I can create non-singleton game states as many as I want, but the non-singleton is not possible to create many times. So if you look just at these lines without coding them, is it clear how the singleton have some kind of other features than non-singleton, or is it not clear? Like, are the feature of single instance clear, plus, minus, or not really clear? So the idea is that you have special type of way how to write the class, so you would not be able to create this class two times. You can only create this singleton type of class once. Okay, so I have one minus. It would be great if there would be any like follow-up questions, then I can explain a little bit more. So the idea is that you have the way how you write the code is structured in the way that that you cannot create the class multiple times. You can only create this type of class, which is singleton, once, because inside the object there is some kind of restrictions that will create, if you create it second time, it will generate error for you. But maybe it's not clear, because let me show you also another part here. So let's imagine that we have not only score here, but we will have some kind of static global score, another variable. So we have two variables here in this non-singleton, okay? So this will be the static variable. So the static variables are not written inside this scope where we have self dot something. This is very, very kind of confusing. You need to write static variables in this way in the classes before the functions. So before the functions. So what's happening here is that if I'm trying to now write a static global score like that and set this to let's say 50, and then I go inside here and set the static global score to 60, then something strange will happen, because the static global score 1 will also become 60 automatically, because again the location of memory for static variables are the same for every single instance in the code. Like all of the instances of the code that have static variables have the same memory location. Okay, this might be a little bit confusing. So I don't blame you if you don't catch up with this. So I will drop these things into Jamboard, and I highly recommend that basically for the that you try to play with these a little bit around. I will also rewrite in a little bit different manner up here these things. So first of all, we don't need always to call it like this with the game state. We can also call it using self. It's just that this will be the same for all of the instances. So if I add it like this, oh no, I cannot I cannot actually call it inside the static function with the self, but other parts I can do that. So again, don't worry that you don't catch with this. I will drop this in the Jamboard as well, and you will need to implement that yourself in a home and try to integrate that in the game. I will try to show you how, but meanwhile we will do other things. So before we move to the other things, what you will need to implement here is following. So you will have to have here not only score but also elements. You will also need to have the player, and so the player by default will be none, but you can set it to basically player. So I can actually set it here like that. And you also have the self is game running false or true. So the even if you don't understand exactly how this works, you can start playing with this, because basically what it means that you can at any part in the code, like anywhere in the code, you can just call game state dot is game running and access directly this kind of object like the value there. You can also at any part in the code just call elements, append something like rocket, and it will also work. So it's kind of like global variables, but they are clustered together in a group. So you have 4 variables here that are clustered inside this game state structure. So I will also add this to the Jamboard. So even if you try to write this now and you have some issues with it, please later go to the slide number 5 and try to carefully copy this code and play with it. So you should implement that, of course, in your game code, not outside the game code, because the player is not known right now. But don't worry. So we will return to something that you already know. Okay, so I just realized that Singleton explanation was a little bit maybe too difficult, but you will need to play with this yourself a little bit, think about it, and then hopefully next time we can return to this. So let's go back in the template. So in the template, let's forget about the singleton for a while, and let's make that everything works a little bit better now. So first of all, we need to implement stop function. So in the line 189. So it would be very nice if we like lift our finger from the button, the player stops, not just like keeps flying. So how to do that? Let's then scroll up to the movable element and implement here very simple function def stop, and this function will be self direction x is 0 and the y is also 0. So not by actually adding the vector values, but just like setting the values to the 0. Very simple function. I believe all of you can understand this function very easily. So you should add the stop function. So I will add this part of the code to the Jamboard slide number 6. Again, for a while, forget about the singleton. You will return to this very slowly in the homework. Don't worry about this. So now the stop function is here. So that's great. I added that to the Jamboard, so you should add that to the movable element. Then the player should also be able to fire rockets. So let's add the rocket function here. So def fire rocket. By the way, I don't need to don't need to manipulate with rockets outside of the player, because the player is the one who is shooting the rockets. So that's why I can do this here. So, but before we do that, we have not defined rocket class, so I forgot about that. So let's add another class that is kind of movable element, and we can delete actually the rocket function for that, and this will be rocket class. Rocket class. Actually, I also have the symbol here that we can use. We can use this one. You can use some other symbol if you want, and this speed will be 2.0. So this will be the rocket, and we could even set direction directly here. So it should be possible, I think. Direction dot y will be upwards, or we can just call up. So it would be strange to do that. So self up like that. So that's great, because when we create a rocket, it immediately starts flying upwards. So that would be nice. So we can define everything inside just few lines. So then for the creating a rocket, so we will create it here. We would not create some kind of rocket that is shared with all of the code. So we will create many rockets. We can fly, we can shoot like 10 rockets at a time. So that's no problem. So rocket here. Then the rocket position, that's already something we discussed today. You know already how to do that. You need to copy the position. You cannot just assign the position. So self position x and self position y, and I would like to have that it looks like that it's flying out of the spaceship. So that's why I will add +1. I think in that way it will look like it's so the frame will render like that it's flying out of it. Otherwise, if I don't add this, it will immediately already skip the first step. At least I think like that. So we'll see. So we'll have the rocket added, but it will not be rendered, because everything that's rendered are only. Oh, I see the questions. Just a second. If I write a static private member variable none, can make a class in a singleton. Not sure what you mean by that, but so just a second, I will return to this, but let me show you here. So first of all, the none means that it's not set, okay? I cannot do something like this immediately, because the object is not yet loaded into like program memory. So I first need to load all of this block of memory, block of code inside the Python, and then when it's loaded, then I can initialize it here by default. Like inside itself, initialize it the first time. Basically, if I would want to create the singleton in a little bit not so nice manner, I could maybe delete these lines, and then I could just create the instance outside here. It would also work. So, but it's not nice way how to create it. But basically, self-contained way would be something like this. Yeah, you just need to play with this. I cannot really, I think, to help to explain even more if you're not yet started playing with it. So you will need to do that yourself. But now let's turn back to the code. So we have a rocket with a movable element that's moving up with the speed of 2 with this small thing. And then we have player that is shooting rockets, but it will not be added to anything, because now it's like disappearing here. So to add it, what we need to do is then call global elements. So this is where the singleton would be very nice. If we can change, if we can replace the global elements, so what we could then do is just call game state get instance elements and do something with elements. But now we need to call global elements, and that means that every single variable in global state will be needed to call like that. So we will call global elements, and we will add elements, append the rocket. So very easily, so we're adding the rocket here. Hopefully I don't have mistakes. I will drop these few lines in the Jamboard. Really, there's not much code here, so you should be able to catch up with this. We just added only the, so we added only few things now. We added the stop function, we added the player class, I mean the rocket class, and then we added the fire rocket function. Nothing else is added here. Very simple stuff so far. So let's go down here. So look at player controls and location. What I mean by that, I'm not sure. So let's scroll down. So firing the rocket. So that's a little bit easy. So player dot fire rocket like that, and then here player stop like that. So now there are only few things in the code that has been changed now. So I will highlight them and wait for you to catch up so we can do few other things, and then make the game a little bit more fun, and then you will have homework to finish some other parts of the game with the things you already know and with the dreaded singleton. So I mean, you can first try to code all of these things that will be required without singleton, but then try to add it yourself. Hopefully it will be interesting at least, and educating and good. So I added this part also to the Jamboard, by the way, so you can find it very easily. So now what's interesting here, what will happen now if I press and release, it stops. So that's one. The other thing what I can do is if I press the space, it shoots the rocket. Actually shoot twice, so that doesn't matter. So I can shoot another. So you see, I can shoot as many as I want. That's really nice. The only thing is that they are not removed; they are stuck at the end. So that's not very hard problem to deal with. We will fix that very soon. But we need to get to this point where you can shoot as many rockets as you want without any problems. Maybe we should add some kind of delay how many rockets you can shoot at once, but that's really not a problem. So yeah, let me know if you're at this part, this place of the code. So let me type in the chat, are the rockets working? So plus minus if something is not working, look at the Jamboard, calm down, and type in the chat exactly what kind of error, maybe do some screenshot, or I can help you out. So I will wait for you to catch up with this. So I see rocket is done, so let's wait for Christiane as well, and then we will look at a few other things inside the to-dos that we need to add. Again, here, for example, it is global variable game state. Game running. So this could be easily replaced by game state get instance is running. So very easy conversion. I mean, like it's kind of like a prefix, some kind of group of variables that can be accessed from anywhere in the code, and this group of variables is defined only once. You cannot create many types of groups of variables of that type. So for example, here you can do that. Again, you don't need to do this now. I'm just like trying to help you out for the later. Then also the player can be accessed like that. By the way, if you would create the player equals like that, then you can use this sub variable like in all of the other parts. Again, this will not be the copy of the player. This would be just the pointer of the player. So it means that if I add this line here, then all of the lines below would work great because this instance of a player is just the same memory location as inside here. It's not a copy of the player. It's just the same memory location. So you will need to play with the singleton later. Now let's make it work so far. So yes, I see two pluses. That's excellent. That's excellent. So we have the rockets flying. So let's deal first with rockets not stopping, not disappearing at the end. So how to make rockets disappear at the end? So that's really interesting problem. So we have a rocket here, and for the movable object, we have a function update, right? Why not use the same function? But we will not code it here, of course. We will not disrupt the base code. We will create the object-oriented version of it. So we will create the kind of polymorphism, if you will. So if you will write here, def update like this, we can override the update function just for the rocket. For all other objects, like for the player, everything will stay the same. So what we do here then is call super. So the super, we will call the update delta time. So we will call the super update delta time, which is the movable object element update function. This part of the code is just called using this small line. And then afterwards, very easy stuff here. So if then the self position, I mean position, position y is equals 0, so we've flown to the top of the screen, then we need to remove this element from the elements list. So what we use is the global elements. So we initialize the elements list from the global space, which again is not optimal, but let's stick with it for a while. When you use the singleton, then you don't use globals at all. When using singleton, globals not needed at all. So then here will be the elements remove, and we will remove the pointer of itself, of course, because the self is actually the instance of a rocket. We will find that instance in the elements array, and we will just remove it. Very simple. So let me check. So now if I will actually copy this part in the Jamboard, and hopefully it will resolve in this kind of polymorphic object-oriented manner. In a few lines, it will completely solve the problem with rockets not disappearing at the end of the screen. So I'm dropping this in the Jamboard slide number 7. Now if I run it, let's see if it works. So let's try to shoot the rocket. So rocket is shooting. It's going upwards. Let's see if it disappears without error. And it did not disappear, which is strange. Let me see what's happening. So I know why it didn't disappear. So remember, the positions for us are the floating point variables. So we need to uh, convert them to the non-floating point variables, and it might be smart to, oh, it doesn't matter, just use the floor function, the integer. So now it will work. Oh, sorry, I will copy that and add to the Jamboard, because the floating point variables allow us to create this smooth flying, and also so that it would work regardless of the CPU time, how fast is the CPU, how fast the user presses the buttons, all regardless of that. Basically all of the computer games work in that manner. So then if I run it again, let's see if it works. So let's shoot it again. Hopefully it will reach the top part and then it will disappear. It will be removed. Yes, it's removed. So great. It works. We can shoot as many rockets as we want and they all will disappear. Okay. So that's great. Now the last part missing is the actually collision with the walls, so we can shoot the walls down, right? So that is not optimal because you want your walls to protect you, but still you can do that. So let me first check that you're done with the rockets disappearing, or so are rockets disappearing at the top? Plus minus, if something is not working, let me know. And then the last thing we'll do is to create that we can shoot down the walls. Okay, I see 2 pluses. That is excellent. That is, you're really doing a good job. So that's great. So then let's see yeah, so see, we need to check the type, and then we need to remove the elements, and lastly we need to create a small explosion. That would be really nice. So first of all, let's check the types. So checking the types might not be that beautiful of a code, but we can do that. So let's write element A. So this will be element A. So let's substitute elements I for element A. So remember, these are pointers. These are not copies of the data. Again, I'm repeating this all the time, but still sometimes people forget that they are not copies of the data. They are pointers because these are complex data types. These are players, walls, all sorts of objects. They are not floating points or integers. So we are substituting, so we don't need to write this long line every time with element A, element B. So element A, check collision with element B. So that's great. Then the next part, actually it would be nice to do this beforehand, is if, so let's do this in 2 parts. So with these brackets, we will separate them. So if type element A is equal to rocket. So see, this is not actually the instance, but this is the class type. And type element B equals the wall, and then or so we will do a little macaroni script. So this is not optimal to write it so long lines, but let's keep it like that so it's a little bit clearer. So here we replace the B with A and A with B. So it doesn't matter in which order they come, it's just that they need to be checked. So either rocket collides with wall or wall collides with rocket. So that needs to be checked. Then you see there's red here. It means that if and if are both at the same tab. Remember, Pythons are very, very important that you have the tabs, right? So we select all of this part, press tab, and now it's great. So this part should look like that. And then the last thing is that we need to remove the elements. So to remove the elements, we do the elements. We already know how to do that, right? Elements, remove element B, element A, like that. And that's about it for the disappearing of the elements. Then there is the explosion thing. So we will do that as well just in a second when you will finish this part. So I will copy this part to the Jamboard. Hopefully it will work. If not, then I will fix it. So in the Jamboard slide number 7, we have the way how we can detect if the instance of this memory location of complex object is that kind of object like rocket or that kind of object like wall. Very important to understand that there are very different things in the coding, like the memory locations of instances, then there are the objects, then there are also the static variables, global variables. All of them have different properties, right? So if I run it now, this part, let's see what will happen. So I will try to shoot down some of the wall. So shooting, yes, it works. It first rocket strike the wall, it disappeared. The second rocket kept flying. So destroy this wall, destroy this wall. Oops, destroy this wall. Okay, great, it's working. So I destroyed all of my walls. Now I don't have any protection. So let's write in the chat, can you destroy walls? So plus, minus, let me know when you can. And then the last thing we'll do, we'll add the explosion, and then we will have the homework. So plus, minus, are you live there? Are you still working on it? You must be also careful how you implement it, because you see here are some of the brackets. They are so there are like in multiple parts. So first of all, there is the brackets around all of this expression, and then also the brackets around all of this expression. So it means that both of them needs to be true, or the other two need to be true. So pair of this is true, or the pair of that is true. Okay, great. It's working for you. Excellent. So now let's make explosion. So the explosion should be also again an object. So this will be non-movable object here at to do explosion in line number 77. So here you will need to find emoji for explosion. I forgot to add it here, but it shouldn't be too difficult, right, to find it. So you can add any emoji now, and later you can change it. Maybe I can drop it also in the chat just in a second. So I added the explosion emoji. So here will be explosion. So the position is what we need. So that's great. The last thing what we need is we need some kind of delay. So delay will be 0.5, and or maybe it's not delay. Oh, it could be delay as well. So, and we can again use the object-oriented features. We can override the update function, which is great. So we can update this thing. Of course, we should call this super update, but even though in this time it's not that necessary. Again, very important to understand how to use object-oriented features, that you can override functions. You don't need to write some kind of awkward code where you do some kind of strange codes in the middle of the game loop. So please do not do that. So self delay minus delta time, and as soon as delay, if self delay is below 0, then at that moment we want to remove the explosion from the screen. So what we do then is global elements remove self, like that. So this will be the explosion code. I will add that to the Jamboard. So the explosion code is added to the slide number 7. And now we'll need only the last part of the bottom here, where we need to actually initialize the explosion. So what it means is that we can create here the elements, append explosion, and we need to use some position here. So not to confuse you, I will use the position of new position, element X, element A, it doesn't matter if you use A or B because they are same position now. And of course, you can rewrite this line in many ways. So this is one way how to write this. You can of course create it in a three separate lines, which would be actually much better. So if we can create a new position here, position explosion, if you create more lines, more detailed code, that is much better than trying to write it in one line. This is the one line macaronis are always much worse. So you cannot debug them, for example. So explosion will be position explosion, and then elements append explosion, like that. So I will, if that works, I will add that to the Jamboard. Now I try to run it, how it looks like. So I'm shooting. Okay, there's a problem. Yeah, the problem is that I forgot that there is a dot position. Dot position. Also here, if somebody want to write macaroni script, which if it would work for me, I would not allow. So run again. So if I'm trying to shoot, yes, the nice explosions, so very beautiful effects. We can shoot down the walls. That's funny. Okay, so it works for me at least. So I'll drop this part also to the Jamboard so you can complete your explosions for your code. So for the homework, you will have to try to play around more with the singleton. So I will add this in the slide number 8. And so you only have to do two things. So first of all, you should play with the singleton and replace the global variables with the singleton. So what are the global variables? They are these. So the player, elements, and this game running. They should not be floating somewhere in the middle of the code. They should be all packed inside the singleton. So that's one thing you should try to do. The other thing is that maybe actually I will set it in a different order so you could have chance to do some simple things. The other thing is that you should calculate the score, like for every destroyed wall, you should count +1 score, even though it's removed protection. So I don't know, or -1, it doesn't matter actually. And then the third thing is please implement also the small spaceship on the top of the screen. Maybe I can point what I mean by that. Please do not implement the aliens itself because we will look at other design patterns for the aliens that we want to implement. But even if you do that, that will be really fun and nice that you do the game like further down the road. So what I mean is that we already have this part, we already have this part, we already have the rocket here. Please implement the score. So that's one. Please implement also this small guy up here so that it's flying just like time to time from this direction, time to time from that direction, that you can try to hit him. So it will be really fun and interesting how to aim to hit that small alien ship up here. So please do that. And then the third thing, please try to implement the singleton. So I would suspect that please do the singleton only if you understand it. If you don't understand it, then maybe do two files. First, do the score and the alien, and then in the second file, try to implement the singleton. And if something not works, then at least you have one part working. So hopefully that's clear, and hopefully that's fun stuff for today. Yeah, so we'll see you next week. So these tutorials we have every week, they are from very basic still really advanced stuff. So it will take a while. So if you're just joining now, you can start working from the first ones. We will implement this first in the Python, then we will implement that in the JavaScript, then we will implement some other games, and yeah, so see you next week. Okay, bye bye.